Welcome to today's session on Spanning Tree Protocol (STP). In this video, we'll explore how STP operates within switcher networks and demonstrate its implementation using PNET Labs. We'll examine the road bridge election process, port roles, convergence behavior, and the configuration of PortFast for the optimization of the access port performance. We'll discuss about the PortFast also in this particular video. First, let me take some three switches. I'll take Cisco IOL L2 switches. I'll take some three switches. I'll name them as SW. I'll take that image of a switch. Done. I'll arrange them in such a way that looping is created. Now I'm connecting all these three switches. Connected all the three switches now. I'm turning on all the devices. Is now spanning tree protocol is done now. Actually, the looping has already formed. To avoid the looping, spanning tree protocol has already elected one of the switches, the root bridge, as we discussed in the theory section. So let us find it out, which is the root bridge. So I'll go into one of the switch. Enable and conf here. Let me change the host name to SW1. Then similarly, I'll take another switch also, switch 2. Enable, configure terminal, host name SW2. Similarly, let us take one more switch also. Again, host name, I'll give it as SW3. Now it is done. We can see which is the root bridge among these three. I'll exit from this and then go with some show commands. Show spanning tree. See, now it is giving me the information that spanning tree protocol is enabled. Root ID priority is 32769. Actually, it is 32768 plus 1 VLAN. So it is 32769 is the default priority in all the switches. And this bridge is root. As we have discussed, the root bridge is elected based on the BPT you got, where it will calculate based on the MAC address and the priority ID. And since it is having the highest priority, it has already been elected as the root bridge. You can see that in the root bridge, all the ports which are connected to that root bridge are in the designated and the forward ports. There is no blocking port in the on the root bridge. All are in the designated ports. Now, let me go to switch 2 now. We will see same thing. Exit, show spanning tree. So now this bridge is having the same priority, but whereas I have a MAC address. Whereas here, if you see, uh, again, all the ports are, see, three ports are designated ports. We can see here, E01, 2, 3, 01, E0, 2, 3 are designated ports here. Whereas if you take this Okay, E01, E01, 2, it is designated ports here. And if you take it here, um, all again they are in the forwarding ports, and one port is the root ports, or another three are the designated ports in this switch also, and there is no blocking here. We will take the third switch also. In the third switch, one of the port should be in blocked state. Um, Only then we can avoid the loops. We will see that show spanning tree. Yes, we can see here. EET 0/0 is the blocking port, whereas all the other ports are forwarding ports. So one of the port 0/0 is blocked, which means in this way 0/0 and 0/0, this is the blocking port here. Based on all the negotiations by BPDU, it has been decided this has been the blocking port, and these two are the designated ports, and these two are the um, root ports, and this is again a designated port here. This is all about the spanning tree protocol. Now, what we will do now, as per this theory, um, we know that SW1 is the root bridge. You can see here the bridge is the root. Now, I need to make SW2 as the root bridge, because as I told, which is the one which is called as the root bridge is becoming the hero of the complete network topology there. So suppose what is the cases? So this switch is the root bridge now, and I am purchasing a new switch after some 10 years. So in that case also, again this will be my root bridge. It will be in root bridge. So the new switch I should manually make it as a root bridge. In the theory session we have discussed like priority ID can be changed. So we will change the priority ID of SW2 lesser than the priority ID of SW1, so that this SW2 will become the root bridge forcefully. We will try it out. So now I'll take SW2. So SW1 priority is 32769. So I should make SW2 priority ID lesser than 32769. Normally priority ID should be in terms of 4096 4096. In that way it should be in terms multiples of 4096. So what I will do here, um, I'll go with conf team mode. In the configuration mode, what I'm going on doing is switching spanning tree. I'm making it VLAN 1 priority. I'm giving forcefully the priority lesser than the 32769. So the lesser value is 4096 is much lesser than the 32769, and it is a standard value again. So I have forced it to be 4096. Then I'll exit from this mode. Then what I'm going to do, I'll go to my switch 1 now. I'll again go with the show command. So actually this bridge is the root bridge because of the priority and the MAC address, least MAC address. Now what I'm going to do, show spanning tree. See now, this bridge is not a root bridge now. This bridge is not a root bridge now. There's no message on this. So I'll go to switch 2 now. Let me go use the same command, show spanning tree. So this bridge should be the root. Yes, see here. Since it is having the priority ID 4097, which means 4096 plus 1 VLAN 4097, which is the having the highest priority, since it is having the least value number, since it's least number, so it is highest priority. So this bridge is the root. Let us try with um, same 4097 we have on. Let it try it with this one. So let us go with one more trial. I'll go to switch 3. Okay, I am going to do it 0. Let us see whether it is working out or not. Conf t spanning tree of VLAN 1 priority. I'm going to give priority as 0, which means this is highest priority switch 3. Okay, then I'll exit from this mode. Now I'll go to switch 2, and whether we will see whether this is still a root bridge. Show spanning tree. So now this is not the root bridge now. So SW3 we will see now, or show spanning tree. See now, this bridge is the root, which means it is a root bridge since the priority is 1, 0 plus 1. 0 is the priority I have given, 1 is the VLAN 1. So 1 is the priority. It is very lesser than all the other priority value. So this is my root bridge. So what I want to say is priority numbers can be manually changed based on the switches which we need to become the root bridge. It is possible to do that. Okay. So now we will see that root ports also we can see. Already we have seen the root ports. I'll just show you once again. These are the root ports, designated ports. All these are the designated ports. Since it is a root bridge, and here we will see show spanning tree. So we can see that this is my root port is 0/1 is my root port, and this is my alternate paths, which is blocking part. It is this block will be enabled when one of the path is down. Okay, then this path will be enabled. All other parts are the forwarding and the designated ports. This is all about the ports. Now we will see the states. We have three states, as I said, listening, learning, and the forwarding and blocking state. What we will do, we will take one of this switch. Let me take this switch and one of the port, let me go into down. Let me take this switch once, switch to E01, E01 to be down, E01 to down, switch to, okay, E01 to down. So what I'm going to do, conf t, I'm going to take this interface E0/1. I'll make it to shut down. Then I'm again going to make it as no shutdown. Okay, that's all. I'll exit from this mode. I'll see what happened actually. I'm going to use the command show spanning tree interface if interface E0/1. I'm going to use the command detail so that it will give me the detail what it is happening. See, it is moved into learning. Now, again, when I give, it should go into my listening stage, right? A forwarding stage or blocking stage. I'll give repeat the same command. Yes, see, it is not root forwarding stage. So listening stage, learning stage, and the forwarding stage we can see here. Same thing we also can write out to see that it is listening, learning, all these things is we can see them by this. Now, all these things will take around 50 seconds as we have discussed. Then to move into forwarding and blocking states, it will take some 30 seconds. I don't want to wait for that much time. So I want immediately to go into forwarding mode port or blocking port. For that, I have a command called as the PortFast. PortFast is used on the access ports. What is meant by access ports? Ports which are connected to the PCs. So what I'm going to do, I'll take one PC, one virtual PC, I'll take it randomly. I'll connect this PC to one of the switch. I'm connecting this switch with this PC. I'm turning on this machine. That's done. Now what I will do, I'll use the command here. I'll go to this switch. Go to this switch. Yes, switch to. What I will do, which port I have taken here, E0/2. So I need to conf t interface E0/2. What I'm going to do, spanning tree port fast port fast. So no, port fast should be enabled only on the ports. So port fast has been configured on Ethernet 0/2, but will be have an effect when the interface is on non-tracking mode. That is what now we can see here will not go into listening or learning. We will see that also. So exit will not go into listening or learning mode. That we will see once. Exit. I'll use show spanning tree. Um, interface. I need to check with E0/2 detail. I'll use the command detail. So it will give me, it is going on to forwarding mode. It is not going on listening or learning mode. That is what specialty with the PortFast, because see, we can see this port is in the PortFast mode. So that is why it will not go into listening or learning stage. But the very important parameter with the PortFast command is PortFast should not be used on any of the trunk modes, or should not be used between the switches. Once we are using between the switches any PortFast command, in that case again the loop formation will be there. So always PortFast command should be used between the switch and the end device. In the access modes when it is there, we can use the command PortFast from the switch to the end device. In that case we can use this PortFast command. That's all about this particular video on spanning tree. If you have any doubts, you can just ping me out. Thank you.